Silence held a 600-ton giant for half a century, its fire cold and its legend fading into scrapyard rumors. Union Pacific 4014 waited while diesel power took over and steam seemed finished. Then a bold plan took shape, driven by engineers willing to risk reputation and resources to wake the largest steam locomotive ever built. The effort reached far beyond machinery, tied to pride, memory, and the raw promise of American engineering. How do you resurrect a machine built for mountains and war? And why did millions care enough to see it breathe again? A decision made in a quiet room set an unlikely chain of events in motion. Long removed from speed and steam, Union Pacific 4014 stood dormant beneath layers of grime and fading paint, surrounded by weeds and forgotten track. The locomotive remained massive beyond comparison, weighing more than 600 tons and stretching farther than many urban intersections. Its proportions alone hinted at a time when American industry believed size and strength could solve any obstacle. The defining feature of this machine, the 4884 wheel configuration, was engineered for one purpose only: to move overwhelming weight across unforgiving terrain. During the early 1940s, the Wasatch Mountains tested the limits of rail transport, with grades steep enough to cripple smaller engines and delay cargo vital to a nation consumed by global war. Alco responded with the Big Boy class, producing 25 locomotives built to endure constant punishment without retreat. These engines hauled thousands of tons through snow-choked passes and high-altitude corridors where steel groaned and crews pushed forward regardless of exhaustion. Time eventually replaced steam with diesel, and silence followed. Yet every rivet on 4014 still carried the intent of an era that measured success by what could be moved, not how easily it could be done. That silence broke in July of 2013, when responsibility shifted from preservation to revival. Union Pacific and museum leadership finalized an agreement that reshaped the future of 4014. The locomotive would leave static display and return to the railroad that built it, while another historic engine would take its place. The commitment extended beyond transport or restoration, reaching into public trust and long-term care. Planning began immediately, anchored by the reality that the journey itself posed serious risk. The route from Pomona, California to Cheyenne, Wyoming, covered 1,390 miles of active rail, bridges, curves, and elevation changes. Engineers analyzed clearances and load tolerances, while crews prepared temporary track panels to free the locomotive from its resting position. Once movement began, the operation became visible to the nation. Communities lined the route, gathering by the thousands as the Big Boy passed through towns at walking speed. Many spectators had never seen a steam locomotive of this scale outside books or film. Others recognized the sound of steel wheels and felt memory return without warning. The convoy stopped repeatedly for inspections, weather delays, and unplanned issues, including a derailed support vehicle. Each pause drew larger crowds. By the time 4014 reached Cheyenne, the move had transformed from logistics exercise into a shared national moment. Arrival marked the beginning of a different challenge. The Cheyenne Steam Shop, though historic in its own right, lacked the clearance and lifting capacity required for a machine of this size. Work began by stripping the building down to its structural limits. Old ceilings collapsed under controlled demolition, sending decades of debris to the floor and allowing light to reach areas long hidden. Walls were modified, reinforced, and repositioned to gain every inch of usable space. The most critical upgrade came from above. A new overhead crane, engineered to lift 40 tons in a single operation, was installed after weeks of reinforcement and alignment. Steel beams weighing thousands of pounds were set in place with precision, transforming the shop into a facility capable of supporting modern restoration work at historic scale. Once operational, the crane allowed crews to move major assemblies with accuracy and safety. New windows illuminated freshly painted steel and heavy tools arranged with purpose. The space no longer resembled a storage site for aging equipment. It became an active industrial environment ready to meet the demands of a full-steam rebuild. Inside the boiler, restoration shifted from structural preparation to detailed evaluation. Experienced boiler workers entered through narrow access points, their headlamps tracing the curved interior surfaces. Decades of inactivity had left corrosion in critical areas, and every inch required documentation. Ultrasonic testing measured steel thickness to the hundredth of an inch, highlighting weakened sections that demanded attention. Chalk markings spread across the shell as crews identified components slated for removal. Nearly 500 stay bolts securing the firebox to the outer shell had to be removed individually. Each bolt required cutting, heating, and extraction by hand in confined space. Replacement bolts were machined from modern certified steel, installed with strict torque specifications, and inspected using dye-penetrant and magnetic particle methods. Inspection results were logged and verified continuously. The process consumed thousands of labor hours and demanded steady focus. Apprentices learned through repetition and discipline, while veteran craftsmen relied on experience refined across decades of steam-era practice. Below the boiler, attention turned to the locomotive's suspension system. The original leaf springs, forged during the 1940s, had supported immense weight under extreme conditions for decades. Testing revealed cracking and fatigue that ruled out reuse. No existing supplier could replicate the required size and strength. Metallurgist Dr. Robert Kleen revisited original Alco documentation before selecting SAE 5160 steel, a modern alloy known for its resilience under repeated stress. Custom forging tools were designed, and furnaces operated near capacity as each spring took shape. Heat treatment followed strict cycles to ensure proper hardness and flexibility. Every finished spring underwent proof load testing at 18,000 pounds. The steel flexed as designed and returned without deformation. Completion of the final approved spring removed one of the largest structural unknowns from the project. Attention returned to the boiler for one of the most critical tests. Inspectors sealed every opening and filled the vessel with water, eliminating compressible air. Pressure climbed steadily as gauges were monitored in silence. On February 6, 2019, the needle passed 375 pounds per square inch. For long moments, nothing changed except the hum of equipment. No leaks appeared, no drops formed along seams. The boiler held. Quiet pride spread through the room, marking a milestone that confirmed the locomotive's structural integrity. With that success, the project shifted from restoration to preparation for fire. Fuel systems reflected a careful blend of tradition and control. Coal firing had been replaced with No. 5 fuel oil, delivered through custom piping designed for reliability and precision. Steam-assisted atomization converted the oil into a fine mist inside the burner, allowing even combustion across the firebox. On April 9, 2019, ignition began. A spark crossed the burner, and heat filled the chamber. Steel expanded with audible response as vapor escaped through the stack. Sounds long absent returned to the shop, signaling the end of dormancy. News spread quickly, drawing onlookers to nearby tracks as steam once again marked the presence of the big boy. Initial movement followed weeks later. On May 1st, beneath Wyoming skies, Union Pacific 4014 rolled forward under its own power for the first time in nearly 6 decades. Motion came smoothly, supported by months of testing and careful adjustment. Trial runs expanded outward, including a journey toward northern Colorado. Rail corridors filled with spectators, many standing for hours to witness the locomotive's passage. Cameras flashed and cheers echoed across open land. Each mile reinforced the success of the effort and confirmed the machine's readiness. The public debut reached its peak on May 9th in Ogden, Utah. Thousands gathered as 4014 arrived to meet Union Pacific 844, another survivor of steam-era railroading. Positioned face-to-face, the two locomotives represented continuity across generations. When 4014 sounded its whistle, The moment carried weight beyond sound or spectacle. So it reflected years of labor, technical problem solving, and belief sustained through uncertainty. Today, you can still feel it before you see it. A low rumble in the ground, then the whistle, a sound that doesn't just travel through air, but through time. Big Boy 4014 is running today, right here in our world of smart sensors and climate goals. And somehow it fits. It's more than a museum piece on wheels. It's a statement. Someone once built this thing not just to move, but to last, to mean something. Every puff of steam feels like a breath of that old intention, the kind of craftsmanship that said, build it right and it'll outlive you. And look, there it is, holding its own beside silent electric engines and automated signals. Proof that we don't always have to choose between where we've been and where we're going. Sometimes we can carry the best of both. What does it make you feel when you see it? Tell us in the comments. Subscribe to our channel for more such videos, and we will see you in the next one.